Girl Scouts, I'm Jamie, Program Manager STEM for Girl Scouts of Central Indiana, and I'm excited to bring you this week's STEM challenge. It's all about roller coasters. In a moment, I'll give you some additional information about your challenge, but first, as you can see, I have a model roller coaster set up to help me explain just how they work. There are two concepts from physics that I want to share with you that are important when designing roller coasters. One is the idea of energy transfer, and the second is the idea of forces at work. Let's start by talking about the two types of energy that we experience when we're on a roller coaster: potential energy and kinetic energy. Kinetic energy is easy to see. It is the energy of movement. Potential energy is the energy that is stored by an object. When the energy in a system switches between potential energy and kinetic energy, this is called energy transfer. When a roller coaster reaches the top of a hill, all of the energy in our system is potential energy. But once the car goes over the top of the hill, the energy in the system is transferred to kinetic energy, making the car move and continue forward. Thus, when designing a roller coaster, engineers need to think about how much kinetic energy is needed to get the car through the ride, and then they find ways to create enough potential energy. So let's take a look at our energy transfer. You can see our cars are at the top of the hill, and then when they go over the top of the hill, the energy is converted from potential to kinetic. The other concept from physics that roller coaster engineers find particularly important is the idea of forces. A force is a push or a pull on an object. And in the case of a roller coaster, we focus on the forces on a roller coaster car. In order to store enough potential energy for the roller coaster to travel through the rest of the ride, we need to get it to the top of our hill. But when our cars are at the bottom of the hill, it doesn't have enough energy to get back up the steep incline to the top of the hill. So we need to add a force to pull it to the top. In this case, we have a motor and chain system that will pull the cars back to the top. But once it's at the top, it now has stored potential energy. And it has enough potential energy to travel through the rest of the path. But we need a force to give it a kickstart to transfer that potential energy into kinetic energy. The force here is one that we are all very familiar with, as it's the same force that helps keep us connected to the ground. If you said gravity, you're right. Gravity is the force that pulls an object towards the earth. When a roller coaster car makes it over the top of the hill, gravity takes over, pulling it back towards Earth. At this time, the energy in our system is transferred from potential to kinetic energy. It is the amount of energy that is transferred from one form to the other that allows our roller coaster to race down the track and through the two loops in our system before coming to a stop. There is one more force that we need to talk about that is at work here. And that is part of the reason why our cars can't make it back up to the top of the hill on their own. And that force is friction. Friction is a force that slows things down. In this case, as our car travels along the track, the wheels rub against the track, and which causes friction, and that force to slow it down just a little bit. By the time our car reaches the end of the track, friction has caused the car to come to a stop, so we need our mechanical force to pull the car back up to the top of the hill again. Let's take a look. So you see our mechanical force pulling it to the top, gravity kicking in, and then friction slows it down ever so slightly until it gets to the end. Now for your challenge. We want you to design and build your very own marble roller coaster using the items that you can find around your home, such as cardboard tubes, paper plates, paper or cardstock. Get creative and think outside the box. You could even use things like pool noodles, or in this case I have pipe insulation. A couple of things you do need to make sure you have: a marble. We recommend a cup to be able to catch your marble at the end of your roller coaster. And then things like some kind of adhesive. We recommend either duct tape or painter's tape seems to work the best. But this is where you get to let your imagination be your guide as you search your home for potential building materials. Remember to get adult permission and support as you work on this project. We also recommend that you use the following guide to help you build your roller coaster. Don't forget to use what you've learned about energy transfer and forces, as well as the engineering design process, to aid you in the creation of your roller coaster. We'd love to see a picture of your finished roller coaster. Check out the video description below to find out where to send your finished photos. Good luck, and I'll see you next week with a new STEM challenge.